So welcome to using gettimermanager. We're going to go and get the timer manager from the world in this video, and what we're going to do by the end of it is just have the projectiles that both myself and the enemy tank fire, rather than just accumulating in the scene, they're going to destroy themselves after 10 seconds or a reasonable amount of time. So let's get in and make that happen. Okay guys, so let's take a look at these projectiles in action. I'm going to fire at the enemy tank a few times, and then I'm going to depossess and just observe a few things. Firstly, the projectiles are not being destroyed, which can mean, and it's a difficult bug to reproduce, but it can mean that projectiles can actually hit each other in the air, and we can kind of stop the enemy tank firing by cluttering the area with projectiles. As I say, it's a hard problem to reproduce, but what I'm trying to do is end up with a projectile effectively stuck to the barrel of the other tank, and then he can't fire and I can't fire. It's not happening for me now. It is a tricky one to reproduce, but we don't want these things hanging around in the world anyway. So what are we going to do about that? Well, we have these collision meshes, these brown collision meshes on. Just turning them invisible wouldn't get rid of the problem that the that the projectiles are still sitting around in the world, even though we may not want them. There you go. I did it in the end. If I depossess now, let's go look at what's happened. You see the two projectiles have caught each other in midair. Now that we just get all the projectiles piling on top of each other. It looks kind of crazy, doesn't it? Okay, so what we want to do in the C++ code is when we actually hit something, we want to destroy the collision mesh. But before we just blindly destroy it, if you look at the projectile, remember that it's the root component. Let's get in the habit of thinking about whether or not we're destroying the root component. If we are, let's set something else first. So I'm going to set the impact blast as the root component, then destroy the collision mesh in the code. Okay, so it's not super difficult. Set root component, impact blast. There you go. And I'll put these as kind of a pair, and then we're going to destroy. Sorry, we need to go to the collision mesh. It's a function on there called destroy component. Great. Okay, let's have a go at that. Let's see what that looks like. Recompile. And what we should have is that because the collision meshes have actually been destroyed immediately on impact, this situation should then be impossible. And if it is, then we can even turn off the collision meshes. I don't think we're going to need them anymore, these brown collision meshes. So now, obviously, just firing it a few times does not prove that the bug has gone away. But I think we can reason that the bug must have gone away because the collision meshes are destroyed immediately on impact. Okay, that's cool. Now, I don't like these black puffs of smoke that are hanging around after the projectile is destroyed, so I'm just going to go and look at the projectile blueprint actually, I'll look at the impact blast particle effect. I think what it is that my impact blast has still got a smoke trail emitter. I don't need that, so I'm going to delete my smoke trail emitter from the impact blast, and that should stop that funny business about them hanging around. Let's just take a look how this looks now. Yeah, we've got a little puff there, but that's okay. What we haven't got is those black smoke trails hanging around. Okay, so continually as you go through this, play with the parameters of your impact blast and your launch blast and get things how you want them. But what we've got now is another problem with these projectiles, which is that if we look on the right-hand side in the world outliner, every time we fire a projectile, they may well have their collision meshes destroyed, but they still exist in the world. And after not much gameplay, we'd have a massive number of projectiles, projectile BP7, BP9, BP10, and this is a memory leak. This is creating things without destroying them. We're not tidying up after ourselves. Eventually the game would crash. It might take a while, but we need to tidy it up. So we need to come up with a scheme for destroying our projectiles. So let's just discuss the possible schemes. One is to use a projectile destroy timer. We're going to use that one. It's very simple, and the projectile becomes self-responsible. What we do is we set a timer, and then when that timer elapses, the projectile just destroys itself. The problem, the con, is that it's not very performant if you had hundreds of projectiles, all these timers going. So you could do something else. You could spawn an explosion effect at the impact site and destroy the projectile. So the projectile disappears and a new object starts. It's more physical. The projectile has gone, you could argue, once it's exploded, and the explosion remains behind. It's more complex to do this, and it could cause slowdown just when you don't want it, i.e. just when explosions are going off, you're destroying and spawning objects, not necessarily the most performant thing to be doing. Finally, if you had a natural limit to the number of projectiles in the world, say you took the number of tanks and then worked out how many times a second they could fire and how long the projectiles live, you could say, okay, we can't have more than 100 in the world at a time naturally, so let's just have a pool of 100 projectiles, for example, and then when a projectile lands, you could disable it, and so it effectively disappears and isn't active anymore, And then next time a projectile is needed, you pick the oldest projectile from a pool and you pluck it, put it in the barrel and reactivate it. So the projectiles never actually get instantiated and deinstantiated, but you just have a fixed number of them that are moved around in a circular fashion in what we call a ring buffer in the world. So there's an option for you. We're going to go with the first one, a simple projectile destroy timer. So how do we do that? Well, when we hit, I'm just going to help you get the method, then I'm going to get you to implement it. We need to go to the world because the world has in it the timer manager. So we get the timer manager. Now that we have the world's timer manager, we can call a set timer method on it. Now, set timer is a bit minging in that it has a whole load of different overloads. We're going to go for overload number 6 here, mainly because it does everything we need, plus it has some minimal form of documentation on it. We've done things like this before. You're going to need to make yourself an F timer handle. Just call it timer or timer handle. Immediately above, the class is going to be just this. It is just the projectile. We're going to need a delegate method, which is a huge, look at that massive parameter name there, but it is a simple delegate method on timer expire or something, which you'll write, and then we won't loop. This timer isn't going to loop, it's going to go once. All right, so that gives you enough of a clue to do this challenge. Make the projectile self-destroy. I want you to use that method. Set a blueprint editable destroy delay, so we don't have to keep recompiling when we play with our destroy delay. Write a simple delegate method. In that delegate method, just use the destroy method to destroy the projectile, test that it works, and then go over to the community.gamedev.tv and comment on the whole approach and which one you chose. So go ahead, do that challenge, and I'll see you in a minute. Okay, welcome back. So let's get this timer thing going. So what do we need? We need a timer. So we're going to go F timer handle. Unfortunately, we're just going to throw this away, but it's an out parameter and we must provide it. So there's the timer. We're going to ignore what it says here because this is overload number 2. We want number 6, so we could go to get to 6 there. So what does it need next? Well, it needs a reference to ourselves, this projectile. Then we need to tell it the delegate method. So we're going to call it ampersand a projectile. Or actually, rather than writing it here, why don't I go write the method now? Void a projectile : on timer expire. And I might as well even just write it. We simply just say destroy, which will by default destroy the current projectile. Great. So now the reason I did that is I can just copy a projectile on timer expire. Remember to put your ampersand address of operator in front. That's how you do it when you specify delegates. Destroy delay, which we have not defined yet, and false. Okay, I'll make it a slightly longer line there, but it does all fit on one line. All right, so we need to go and do a couple of things. Firstly, we need to declare this on timer expire. I'm going to use the quick actions to create a declaration of it in the header file. I'm going to pop over to the header file, make sure that it's in a sensible place. I think it is. That's fine. And then I'm also going to declare a timer delay. So it's going to be a float, and it's going to be a destroy delay, and I'll make it a default of 10 seconds or something like that. Better make it a U property so we can edit it. Edit defaults only, because I think we only want to be able to edit it on the archetype, not on individual projectiles. Category equals setup will do fine. Okay, so we have a destroy delay, 10 point maybe we need there. And yeah, we're, I think, good to go. So that's the code I've written, just that, a delegate, and a couple of declarations. Let's go ahead and see if that'll compile. And then crucially, what we do is we fire back and forth at each other, and what we're hoping is that the projectiles will delete themselves out of the list, and we will not end up with an infinitely growing list of projectiles. Of course, the first one won't delete for 10 seconds, but that's quite normal and expected. And we'll go from there. It'll be fun. Good. Okay, so I'm going to leave myself in this smaller view here because I want to be able to see the world outliner, and I can see now projectile BP1, BP2, BP3, BP4, and I'm firing continuously BP5, 6, 7. Now what we should see in a minute is deleted actor. There you go. Briefly you saw deleted actor. I'm going to stop firing right now so that the overall firing rate is lower than the destruction rate, because previously between me and the other tank we were firing faster than this, and now you see the projectile pool is just down to the number of projectiles that the enemy tank is responsible for. So you can see that the hierarchy, or the world outliner rather, is keeping itself tidy now. We are destroying what we are creating, and that's good news. I'll show you the code we've done in this lecture, and then I'll see you in the next lecture. We made these declarations here. Of course, this U property allows us to go to the projectile blueprint to the top of it there, and then we go to destroy delay, and we can change that if we want to. The other thing we did was we popped in and did this implementation here, which I'll just leave on the screen, and I will see you in the next video.